Okay, hi, I'm picking up from number 7. A crazy version of number 7 was at the end of the previous video, but I've cleared my thoughts now. I'm on a little cold medicine, and I think it is addling my mind. Plus, it's very late in the evening for me. Anyhow, enough excuses. I've taken all the things in this picture, and I have color-coded the information as I put it onto the picture. So the things in red are the fact that I have an x-intercept here, and that point is also a maximum. So this has to be like the top of a hill. In fact, I'll add a little bit. That has to be like the top of a hill, okay? These other 2 points on the x-axis are my other 2 intercepts. My y-intercept is up here. I have a note from this part that's in blue that there's a maximum somewhere along here, and there's a minimum somewhere along here. And polynomial functions have to have smooth curves as a graph. So this guy must come up from here, hit that x-intercept that's also a maximum. It has to come and have a low point over here. The orange writing tells me that has to be a minimum. That was from this part of the writing. Then I'm going to go back up here through this x-intercept. I'm going to go up here to get this y-intercept. There has to be a hill even with x equals 1. I have to come back down and I hit this x-intercept again. And then I know I can't turn around and hit anything else over here because there are only those 3 x-intercepts and no more. So it has to look like this-ish, okay? So if both arrows are down, I know that the degree is even. And since both of them are down, it's not the even up-up case, it's the even down-down case. So that means my leading coefficient is negative. All right, number 8. I would say just look at the work here. You're testing for even, odd, or neither by looking at x equals 1 and x equals negative 1. You also could look at x equals 2 and x equals negative 2. Any 2 opposites will do. And you're going to answer even when you get the same result. You are going to answer odd when your results are opposite. So like one's positive, one's negative, but it's the same number other than that. And when you have numbers that are completely different, then you answer neither. Okay, so even is if you match. Odd is if you get opposites. And like weirdo stuff, neither. Okay, if it's neither of these cases, you say neither. Okay, and you're just testing there for symmetry. Remember that even means you have symmetry across the y-axis. So the graph on this side and the graph on this side, like they could fold in half, like the graph could fold in half, and the 2 parts would match. Odd means that you have rotational symmetry. So a branch over here would match with a branch over here if you rotated on that little button that's at 0, 0 and spun it around like a spinner in a game. Okay, question 9. Excuse me. We have 2 pictures here. It says we have one graph they're calling F. I can tell that the black graph is F because of the +1. I moved up 1. And then I can tell that the red graph is G because the slide of over 2 and down 1, that matches what I'm seeing here. Okay, so it looks to me like the x-intercepts of G are easy to see. They're right on the number line there. They're friendly. So at 1 and at 3. And then this went 2 to the right. Remember that the things in parentheses are backwards. And down 1, that's not backwards because it's not in the parentheses. And then you want to identify the minimum point, which would be this center guy here. This isn't exactly a parabola. I wouldn't say it is a parabola. Like, it looks kind of like a parabola. I get that. It's not really a parabola because it's to the 4th. But it still is a graph that has a vertex in the center of its shape. And then you're supposed to look for downhill and uphill. Okay, so this part is going down, and this part is going up. And you want to write those in terms of your x's. So 2 to infinity, and this is negative infinity to 2. Okay, so question 10. I should look at the actual question first. Question 10 says, write a rule for G that indicates the indicated transformation. So I know when I go 4 units to the right, I need to subtract 4 from my x. I'm reflecting over the x-axis, so that's going to flip things over. I'm going to come back to that in a second. So I'm going to multiply by -1. And then the shifting 6 units down, I want to have the whole function of like a -6. So if you take a look at the answers here, you might say, well, where's my 6? Well, you're starting with all this other stuff, right? So that has to come into play too. So one way that you could think about this would be to take like a little middle step. Don't worry about that beginning function quite at the beginning. So say my new function g has to be my old function f. The 4 units to the right is this part. The reflection is this negative, and the down 6 is like this. And now bring in this other equation. So I put x minus 4 in place of this x. So I say x minus 4 minus another 5 cubed, and then I have plus 2, and then this part is reflected. If you tidy this up, oh, and then, excuse me, then you have to go 6 down. I was wondering why this wasn't adding up for a second. And then you have to go down 6. Okay, if you tidy this up, this part is this, here's my minus, and then this part is the -4. That's a very tricky question, a lot to keep track of. Okay, question 11. I'm sorry, I keep coughing. Question 11, you're just taking this picture, and you can see up here in the answer key, this part means to the right 2, this part means down 1. I would take each of these points and move them right 2. So let go, boom, boom, and down 1, boom. That's right there. That's what's plotted there. Do that for each of those points, plot their new location, and you connect the curve. Oh, wait, are we done? Aw, sad, the math is over. Okay, come in tomorrow morning if you're having a hard time and get some more extra help with your teacher. Otherwise, enjoy your quiz tomorrow. It'll be super great. Bye.